Yeah, let's start off in northern Italy. There's something going on. 4.2, which probably is down or was downgraded. Rio Zalicheto. I'm not sure, but Rio might be a valley 7 kilometers in depth. 1 hour ago, 6 kilometers in depth, so they are all shallow. 30 minutes ago, 2 kilometers in depth, and 1 hour ago, 3 kilometers. So, wide rivers. Here we have a few of those. There's actually much more if you watch, like, they're all over the place. And I was collecting, I made a little bit, I made a small collection about wide rivers. Here's one. And here are really big ones. And you can find them in many parts of the world. And I was wondering about these, and I was wondering about many things, like granite mountains, and then we have this kind of limestone, chalk, and here in the middle is where we have all the lakes and stuff and rivers, and also they are digging salt out of the ground in many places in Central Europe and probably on many other places in the world as well. So, back to cryptodomes. From Greek, hidden, secret, is a dome-shaped structure created by accumulation of viscous magma. Viscous? Probably it's both. At a shallow depth. One example of a cryptodome was in the May 1980 eruption of Mount St. Helens, where the explosive eruption began after a landslide because the side of the volcano to fall, leading to explosive decompression of the subterranean cryptodome. And then I was Googling frontiers in earth science volcanology. And I stumbled across this one. Internal structures and growth style of a quaternary subaerial rhyodacite cryptodome at Ogariyama, Uso Vulcano, Hokkaido, Japan. Yoshihiko Koto, Aiki Tomiya. Yeah, I'll keep it short. You can read the whole thing. Let's go down to... Where was it? There was one word which catched my attention. So, I couldn't find it now, but yeah, that's a bit embarrassing. Where is it? Maybe I just should read the text like normal people do. Our knowledge of the natural and formation of cryptodomes remains. Yeah. I guess it was this desitic. Was it? Probably. But anyway, I want to show you still something. Because I was reading about rhyodacite. It's a volcanic rock intermediate in composition between desert and rhyolite. It is the extrusive equivalent of those plutonic rocks that are intermediate in composition between monzogranite and granodiorite. Rhyodacite form from rapid cooling of lava, relatively rich in silica and low in alkali metal oxides. Okay. So, mountain water. My claim about glaciers being volcanoes, which includes a whole lot of water. And check this out, what I figured out about wide rivers and stuff. If you click on alkali metal oxides, list of alkali metal oxides. The alkali metals react with oxygen to form several different compounds, suboxides, oxides, peroxides, sesquioxides, superoxides, and ozonides. They all react violently with water. They all react violently with water. Rhyodacite form from rapid cooling of lava, relatively rich in silica and low in alkali metal oxides. So, this indicates that there is much water in this lava, since there is no of those metal oxides. And now, still to rhyolite is the most silica-rich of volcanic rocks. It is generally glassy or fine-grained in texture, but may be porphyritic, containing larger mineral crystals, and otherwise fine-grained ground mass. The mineral assemblage is predominantly quartz, xanidine, and plagioclase. It is the extrusive equivalent to granite. And it is quite bright compared to other lava, what we have, which is basically black, since it contains a whole lot of metal and stuff and no water. And this is lava, which probably contains a whole lot of water. So if it's not really erupting, there's just probably pouring water out. But if it's erupting like really, there is this stuff coming out. And you get wide rivers. And if we go a little bit further still, Plagioclase, which you can find here. Plagioclase is a series of tectosilicate minerals within the feldspar group, rather than referring to a particular mineral with a specific chemical composition. Plagioclase is a continuous solid solution series, more probably known as the Plagioclase feldspar series. The series ranges from albite to anorthite and members with respective compositions NaAC380 where sodium and calcium atoms can substitute for each other in the mineral's crystal lattice structure. Oh, I missed. So, basically, salt and calcium, if I'm not totally wrong, or chalk, which is white. So this would explain a lot. If granite is altered electrically and it turned into what it is, then the limestone mountains in Switzerland, for example, and many other mountains in Central Europe might be this kind of brighter lava. If you go back here to northern Italy, where we have the Po River Delta, which is really big and really flat. It's really flat. Which also indicates that there could be a really big possibility for this kind of liquefaction event when the groundwater rises up and makes everything really liquid. So now we have quakes here, wide rivers all over the place, and there are the others. This is just a thought. Could these wide rivers actually be this kind of lava flows? There's just so much water involved in those eruption that it actually looks like a river. I don't know. That's really fascinating. Salt, chalk, volcanoes, quakes. Thanks.